Now that we know that how to do the transient analysis and DC analysis, DC operating point analysis, now I want to show you that if you want to do the transient analysis for RL circuit or RC circuit, maybe first order, second order, whatever, you can you need to change this source to some step input. You will give some step input, you can find the step response. You can give a pulse input, you can find the pulse response. You can use the sinusoidal input and find the sinusoidal response. Sinusoidal response might be the current in some element, or maybe the voltage across any element. So this won't make any sense if I don't use a storage element here. So I'll just uh, click this one. Where is that cut? Delete is here, so I'll delete this one as well as this one. So also these intermediate points. So now I'll use an inductor. So I'll just bring the inductor over here and just right click to turn it off. So now I'll just complete the circuit here. From here I'll hover across this one. Okay, I have to click it and then it will connect this one. Then I do the right click. I have to use this move here. So okay, so this is not a good option to make a move because I didn't want to cut it. So I'll right click and then I'll use this one. I'll click this one and then I'll drag it. I can drag it left and right while it is being connected. So in move command, this is detached from the circuit, whereas in by using the current option, this will be dragged along with this mouse here, but it is not detaching it from the circuit. So I'll just click it here. So right click and turn it off. So now I'll choose the value. I want that this should be some since the time constant is L by R. So if I use this, maybe let's take it a small value, 1 millihenry, 1 milli. Okay, and now to find the, because this will definitely give me the transient analysis, means I will get the waveform, but I need to change this DC input to some step input. So how can I do that? If I right click on the source and then I go to the advanced, and here I can find the new settings. So if I want to give a pulse, so this I will activate this one, I will get the pulse response. If I activate this one, I'll get the sine input, and then I'll find the sine wave output. And similarly, if I give the exponential here, then I can find the output. And if you have any particular input like some piecewise circuit, so you can also give maybe if it has a step in jump here and then it's going straight and then some linear slope, then exponential, and so you can give that options over here. You can also use some predefined values, and you can click this one and then browse. You can store some values in the Excel sheet or in some file, and then browse that file and bring it here, and it will take those as an input and it will give you the plot of those um, um, values. Since we are not interested right now in DC values, so make the visible in the schematic. This will be, I think, commented, and it will not give me that value. I am interested in the pulse or maybe a step. So for the step input, I'll just take the initial voltage should be 0. Then as it is on, it should be maybe 1 volt. So this is a 1 volt. There shouldn't be any delay. So I can show you this by using some waveforms. So if I use maybe some pulse input, suppose there is some initial delay. Okay, it is starting from 0, so there is no delay. But if for example like this one, there is some delay here, and then it is going from 0 to some other value, which is, it's not mentioned here, but some on value. So I can give this by value from here. So the initial value is 0, final value is whatever this height is, and this is the delay. So here there is no delay, so if the delay is 0, so you can use this setting 0. And if there is some rise time, you can use that rise time, so that it is not suddenly jumping from 0 to 1, 0 to 1, but it is taking some time. So I'll not use any options here. If this is a periodic waveform, I can also give it a period. So, and also I can also show you the I can also show here the number of cycles I want, as in this waveform we have 2 cycles. So in this waveform we have 2 cycles, so we can say I just want to see 2 cycles, so that would be sufficient for the simulation here. But since I'm not using this one, and also not using this one, small signal analysis, so I'll deactivate it, and then I'll click OK. So, and then I'll place this. Okay, it has been already placed, so I'll move, click on it, and then just drag it to the side. So now this is not a DC input, but I'll make a little bit adjustments here. Just I'll use this one over here, and opt is also, operating point is also activated. So now I can run the simulation. This is the 0 starting value final. Let me check this one. Okay, I'll right click here, time to rise, time to fall, on time. Okay, I have missed the on time. On time would be how long I want to see this waveform, because this is a step signal. I'll just take I'll use a 10 milli here. This is my also the end finishing time or the end time, and this is also the on time. It should remain on till I see it. Okay, so that is okay. And now okay, first of all I want to see this. I'll click here. I haven't set any rise time, but you can see here that it has chosen 1 millisecond as a rise time. And the simulation is shown till the end time. Okay, I have in fact I have chosen. Okay, if I want to select it, I have to click here and then make it visible, so I can show you here. So this is these are the further parameters for the pulse. So we have given those, and this was the 10 millisecond, and this was the on time. So this is on for 10 millisecond, and also this is the end time also. So if I change the finish time or the end time, so maybe this might be, this would be this will be dominant in the 10 milliseconds. So let me check this. If I make it 8 millisecond, okay, and if I run the simulation again, you can see that the end time is dominant as compared to the on time. So but if I change it again, make it 10 milli, and if I change this one, the pulse criteria here, if I make this 8 millisecond, and now if I run this, you can see here that this was on till this time, and then it get off here, but while being off, it took some time to turn off. So I can this would be a very slow rise time. So such a pulse is very slow, it's not responsive. So I'll make some responsive I want that it should quickly go up, and then it should be constant, or it should instantly go down. So I'll make this, I'll just click it again. Okay, so first I press escape so that I'm out of this, and then I just right click here. What I want to do is that I want to set the rise time and fall time. So I'll just right click here, and I want that the rise time is, it's not 0 here. If it is not set, it is set 0 here, but it is taking some time. Okay, let me see also the output first, that how the output is behaving. Maybe I want to see the current through the inductor. It's a voltage across the inductor, but I want the current through the inductor. So the inductor is not being responsive, it is opposing the change in, so it is opposing this change, and then it is, inductor is being charged, and it is okay. Maybe I would be more interested to see what happens next. So I'll make this simulation a little bit longer, maybe 10 times more, to see completely what's going on. Okay, and if I run the simulation again, you can see that since the voltage source is on, okay, maybe I want to see it more. I want to see it for 1 second maybe. You can see the inductor was being charged first, and then it is decaying with the some time constant. So the time constant is important here. This, so you can change these values and see how the time constant can be fast and slow. But anyhow, this is important to know the end time, because that you might have missed the waveform if you have you would have chosen maybe 1/10 of a second. But if you change a long time, you can see what is happening overall, because this pulse is off. It is on for 8 milliseconds, and the inductor must lose its magnetic field over a period of time. So because it will give the energy to the resistor. So keeping in mind that thing, so it must die out. So I'll make it more, I'll increase the time period. So that is how you can tweak the times. Maybe I'm using again 10 times more. Okay, then I'll simulate again. Now you can see the capacitor inductor was being charged, and then it is losing its voltage. So I can also plot its current, and it can also it is displaying the current now. So current and voltage are uh, so I want to see the voltage, current and voltage waveform. uh, Voltage has, I can, now you can see I have increased the time, and I can't see right now here that this was a pulse. So you can miss the information or misinterpret the information, so you have to see the settings, and as well as you should observe the waveform. So to know if something is happening here, I will use this zoom option here. It will, the zoom will zoom every point, but if I click it here and right, this is the left click, and if I place this rectangle over here, this dashed rectangle, it will zoom this waveform. Now you can see also the axis is changed, because I have zoomed this much amount of time. So this is, you can, now you can see here. So this is how you can, okay, I can also using the cursor I can find how long it took to achieve the value of 63.8% of the final value. That would be the rise time, and in this case how much time it took for the inductor to reach the value of 63.8%. 2% of the maximum. So such things can be used by cursor. So you have to right click. You can see the cursor here. But if you click on the waveform, right click, so no, sorry, not the right click but the left click, so the cursor will appear. So over here if I click this one, and now it is showing me this one. But if you need two cursors, so you have to uh, for the second cursor to appear, you have to do the double click, so that will be activated, and you can see one is the voltage and another is the current. So this is about the uh, pulse or step response. So although I have given a pulse here, so if I could have in final time should be more than the 5-time constant of this circuit here. So otherwise I would have missed the information if I would have chosen this finishing time 10 millisecond. So some information, for some information you have to know that what is the time constant of the circuit, and you should at least plot the more than 5-time constant of the circuit.